Okay, so that last video cut short. I could explain to you about the -5. So we got -5 and 1 as our solution. But we can't use -5 because it is considered an extraneous solution. So what do I mean by that? I mean, whenever I plug it into my logarithm, and I just chose one of my logs to plug it into, and I chose the x plus 4 logarithm. I plug in the -5 plus 4, and I end up with a log 5 of -1. Well, we cannot have a negative number inside our argument for our logarithm. It's just not possible. So what we say is it's not possible. We know it can't be -5, so the answer, of course, is just +1. And of course, 1 works because if I were to plug 1 in, it would be 1 plus 4, which is a +5, which means that it can work. So a good rule of thumb is you more than likely will not have a negative answer that works, but always double check. Okay, so now we're going to move on to properties of logarithms and solving exponentials. Remember how we said that if we had a log with a log with the same base equal to a log with the same base, well, we drop them and set the bases equal to each other. Well, the same exact thing applies for exponentials. We have a base x, a base b of x equal to a base b of y. So we drop the b's and we set x equal to y. Well, we're going to do the same thing. First, we're going to practice a couple, and then we're going to talk about having to do a different type of change of base. So if we have 3 raised to the power of x equal to 3 raised to the power of 4, again, we drop our base. And we set x equal to 4. And in this case, we don't have to solve anything else. The answer is 4. We have 6 raised to the power of x plus 1 equal to 6 raised to the power of 3. Drop the base of 6, and we say x plus 1 equals 3. And of course, when we go to solve, we actually get x equals 2. And we can solve it that way. Again, whenever I take that x and I plug it in, we always like to take and plug them in anytime we can. We do 6 raised to the power of 2 plus 1 equal to 6 cubed. Well, 2 plus 1 is 3, so those end up being the same on both sides, so it works. And of course, 2 is our solution. Now for c, of course, it always has to be a little bit more complicated. We have a base of x raised to the power of 2x minus 1 equal to base of x raised to the power of 4x plus 2. We drop the base x because they are the same, and we say 2x minus 1 is equal to 4x plus 2. Well, of course, we solve. I'm actually going to move that 2x to the other side because I like getting positive variables anytime I can. And I'm going to move the 2 to the opposite side. So he's moved. I end up with a -3. 4x minus 2x is a 2x. Solve that. Divide by 2. And I end up with just x equals -3/2. So x equals -3 over 2. And that's my final solution. Again, you can take it and plug it back in. And of course, you should be able to see that you get the same answer. All right, for question 7. This is a different way of solving exponential equations. We notice we have 6 raised to the power of x equals 216. Well, instead of trying to convert that back to a logarithm and go about it the other way, we technically will use a base property where I try to make it an exponential. So I'm going to turn 216 into a base of 6. So I get 6 Guys, I don't know what's going on with my computer. It's being funny. I get 6. Oh, it's going to do it again. Yep. Raised to the power of x equals, well, I need to go into my calculator and I need to figure out 6 raised to what power will give me 216. Well, if I play around with it, I figure out that it is actually 6 raised to the power of 3. Well, once, of course, I get those bases to be the same, I can drop them and say x equals 3. Another method that you could go about using, let's see if my stuff is going to cooperate with me. Let's keep, come on. Okay. So we go to y equals in our calculator, and we're going to put in 6 raised to the power of x. Come on. Oh, nope. None of my stuff wants to work today. I'm sorry, guys. I'm recording from a remote location, not my typical location, and things are just wanting to be funny while I do this. So 6 raised to the power of x, and then we can go to our table, so second table, and we can look for where we get an answer of 216. We see that the answer is 3. All right, so looking at B, well, it's not as straightforward for B. All right, I need to have a base with an exponent equal to another number. Well, I have that, but I have a 2 in front of it that I need to get rid of so that I just have an exponential all by itself on the other side. So I'm actually going to divide by 2 on both sides. So I get 4 raised to the power of x equals 128 divided by 2 is going to be 64. So again, if you don't know how to do this, go to y equals in your calculator. And we're going to make that 4 raised to the power of x, and we're going to hit second table. And of course, we're going to look for where our answer is 64. And again, we end up with the answer of 3. So 4 raised to the power of x is equal to 4 raised to the power of 3. Of course, when we drop the bases, we get an x equals 3. All right, C. Very similar problem. Okay, it's a slightly more complicated, but again, we need our base of 2 raised to the power of x plus 4 all by itself. So I have to move the 5 in front first. So I'm going to divide by 5 on both sides so that I get 2 raised to the power of x plus 4 is equal to, well, 40 divided by 5 is going to be 8. In this case, I know what I can change 8 to. So I get 2, x plus 4 is equal to 2 cubed, because I know 2 raised to the power of 3 is 8. I can drop my bases so that I get x plus 4 is now equal to 3. I'm going to solve by moving the 4, so I get x equals -1. Now, I would highly suggest, whenever we get into much more complicated things, we're going to go in and we're going to solve. So we're going to plug in 5 times 2 raised to the power of, and instead of x plus 4, I'm going to put -1 plus 4, and I'm going to see if I can get 40. Now remember, anytime you raise an exponent in your calculator, you're going to put it in parentheses, right? We get enter. And of course we get 40, so we know that we did our work properly, and we get to say that is our answer. All right, D, we have 2 raised to the power of x minus 5 equals 16. The only thing I have to do for this one is change that 16 to a base of 2, right? So again, if you don't know it, 2 raised to the power of, well, we know 2 raised to the power of 3 is 8. So I'm going to say in the next one, 4. Of course, I get 16. So I get 2 x minus 5 come on 2 x minus 5 is equal to 2 raised to the power of 4. Bases are the same, drop them, so I get x minus 5 equals 4. When I solve, I move 5 I get x equals 9. Again, go into my calculator, and I'm going to do 2. Come on. Anyways, you're going to go into your calculator. You're going to do 2 raised to the power of 9 minus 5, and you're going to see if you'll get 16. You should. Final problem. We have 2 raised to the power of 14x minus 9 equals 32. Well, I need to know, I have to change that 32 to a base of 2. So 14x minus 9. We actually did a problem earlier, so we know 2 raised to the power of 32 is 5. So 2 raised to the power of 5 is what I convert that 32 into. So I get the same base of 2. So I'm going to drop them and say 14x minus 9 is equal to 5. I'm going to add 9 to both sides. So 14x is, of course, equal to 14. So, of course, x is 1. Go and plug it in. Of course, I need to be able to get 2 raised to the power of 5 whenever I do all the work. So my solution is x equals 1. Remember, your calculator is phenomenal. Again, if you don't know how to do it, you can still go in and do 2 raised to the power of 14x minus 9. Close it. Second table. Oh, nope. Come on. I clearly put something in wrong. I don't have my 2 in there. 2 raised to the power of 14x minus 9. Close it out. Second table. Now it should read properly. And of course, I'm going to scroll until I see, 32 is x equals 1. So there are multiple ways for me to go about doing this. Your calculator is a phenomenal way, but you also absolutely need to know how to do this by hand using the change of base. If you guys have any questions, please feel free to contact me. I will check in on you guys later.